In this question, we are given that tank A and tank B, they are in the shape of a right circular cylinder. The interior of tank A has a height of 10 meters. So let's write down all the given data from the question. And the circumference of tank A is equal to 8 meters. Similarly, the tank B has a height of 8 meters and the circumference is 10 meters. We have to find the capacity of tank A is what percent the capacity of tank B. So we basically have to find the volume of tank A by the volume of tank B. Now that we have all the information that is given in the question, let's move on to step 2 and understand the methodology. Now if we denote the radius of tank A as R1 and the radius of tank B as R2, then we have circumference of tank A to be equal to 2 pi R1 and circumference of tank B to be equal to 2 pi R2. Now, since we have to find the volume of tank A and the volume of tank B, we have pi R1 square H1 by pi R2 square H2, where H1 is the height of tank A and H2 is the height of tank B. Now, pi gets cancelled and basically we have to find the ratio of R1 squared times H1 to R2 squared times H2. Now, let's move on to step 3 and calculate the required ratio. Now, if we divide the circumference of tank A by circumference of tank B, then we get 2 pi R1 by 2 pi R2. Now we know the circumference of tank A is 8 and circumference of tank B is 10. Now 2 pi and 2 pi gets cancelled and 2 cancels 8 4 times and 10 5 times. Then we get R1 by R2 is equal to 4 by 5. And in the step 2, we have deduced that we need the value of R1 square by R2 square. So R1 squared by R2 squared will be equal to 16 by 25. Now we know the value of H1 and H2, so let's calculate the required ratio of volume of tank A to the volume of tank B. This will be equal to 16 by 25 times the value of H1 is 10 and the value of H2 is 8. So 8 cancels 16 2 times and 5 cancels 10 2 times and 25 5 times. This gives us 4 by 5. Now since we have to find the percentage, we multiply this by 100 and then we get the answer as 80%, which is the option B.